So we're going to now look at forecast errors. You remember when we talked about the forecast errors, we said that if you have too much of error, you can make costly decisions for the organization. So we want to see how you can look at these errors and see how to make sure that when to make the decision, when not to make the decision, so on and so forth. So you want to look at the forecast error and have a quantitative number for the forecast error so you can decide on things in an intelligent fashion. That is the whole idea of this. Okay, so we have here the period, which is months. We also have the actual demands, and we also have the forecasted demands. So the problem is between these two. So for instance, if you see the actual demand was only 950, but we had forecasted 1000. So there is a problem here of 50. The difference between the forecast and the actual was 50. So we forecasted it wrong, right? So to understand this, we are going to look at how to compute the error values. And one of the things that is going to tell us the error value is the TS, or the tracking signal. So we're going to calculate the tracking signal. In order to calculate the tracking signal, we need to fill up this whole thing here. So let's look at this. What is the deviation? The first thing that I'm going to calculate is the deviation. For the month 1, the deviation is going to be equal to the actual demand minus forecast, and that is going to be minus 50. I'm also going to have a running sum of forecast error. I'm going to explain this to you. The running sum of forecast error is the deviation that you have plus the deviation that you had in the past period. So for instance, the past period, we don't have any number, so I'm assuming it as 0. And so my running sum of forecast error for the first month is simply the deviation, which is going to be minus 50. The absolute deviation is going to be the absolute ABS of this deviation, the absolute number. So it's going to be plus 50. So anything which is negative is going to be positive here. That's what we are doing, the absolute deviation. And the equation for that is ABS, the function for that is ABS, the absolute in Excel. The sum of absolute deviation is going to be, again, how we are going to add anything that you're going to have before. The sum of absolute deviation, right, in this case, is going to be 50. The mean absolute deviation, okay, is also going to be 50. The tracking signal is going to be equal to the running sum of forecast errors, which is RSFE, divided by the mean absolute deviation, which is MAD, which is 50, again BG, but that is now is going to be minus 1. So it is telling me that we are forecasted it in a negative way. That means I've forecasted it more than what is actual. Okay, so I might have bought more materials, supplies and things like that than is actually needed. So that is my error of minus 1. So let's do for month 2. For month 2, the deviation is going to be equal to the actual minus the forecast. So that is going to be a positive 70. The running sum is going to be equal to this minus 50 plus the new deviation that I have for the month 2, and that comes to 20. So the running sum basically is the addition of the deviations, basically, okay, the deviation that I have. So that is minus 50 plus 70, that is going to be 20. The absolute deviation is going to be the ABS of this, this deviation, and that is going to be plus 70. The sum of absolute deviation is going to be equal to the last one plus, so is the last one plus the absolute deviation of the new month, which is 120. The mean absolute deviation is the difference between the average of these two, which is going to be the average of 50 and 70, that is 60. The tracking signal again is going to be the same. I'm going to copy and paste that, and that comes to 0.3333, and I can make this, if I go to home and I can decrease this, see it is decreased decimal, I can make it to 2 decimals. Okay, so let's calculate for the third month. The third month, the deviation is going to be, I'm going to copy and paste this, okay, which is 100, which is 1100 minus 1000. The running sum is going to be, I'm going to copy and paste this, which is 20 plus 100 is 120. The absolute is going to be copy and paste, which is 100, 120. The deviation is 100, so the absolute is also 100. The sum of the absolute deviation is going to be 220, which is 120 plus 100, 220. I'm just copying and pasting. The mean absolute deviation now is basically the deviation, the average of these three. So what I'm going to do is I'm going to actually equal to this plus this plus this divided by this 3, 73.33, and I can make this to 2 decimals. My tracking signal is going to be the same. I'm going to copy and paste this. The only thing that I'm changing here is this, so I can copy and paste these things. It's going to be the same. This one here, I'm going to make it equal to average of, I'm doing both the function as well as the formula. That's for you to learn. So I'm going to use the function here instead of, I use the formula here, I'm using the function here. The average of the absolute deviations for the 4 months, which is this. Okay, and this is going to be the average of the 5 months. And this is going to be the average of the 6 months. Okay, now I'm going to copy and paste this, and I'm going to get my tracking signals. So I can see that, this forecast was really good. This forecast was very good also. This forecast was not that good, but because I have some extra ones before, I'm tracking signal is positive. That's what I'm doing. That's what is happening here. So this is how you calculate the tracking signal. Okay, that ends chapter 3. So we'll go to chapter 4 next.